Security in Drupal, what can go wrong? And of course, the alternative way to pronounce that title is, what could possibly go wrong? And unfortunately, if that's what you actually think, you're in trouble. Did that. Thank you to the Bad Camp sponsors. Hero Devs, Pantheon, Tag 1. No, I haven't worked with Hero Devs. I've talked with several of their people. I haven't actually worked with them. And a few of these others. Introduction. About me. My name is Benji Fisher. The yellow pig is my avatar, and so when I go to a conference, I try to remember to wear the hat, because I sometimes run into people who've met me online and know my avatar, but might not recognize my face. I'm Benji Fisher on Drupal.org, on GitHub, and on GitLab. I'm a member of the usability group. We meet once a week. I'm one of the maintainers of the migration subsystem, or the Migrate API in Drupal core, and I'm a member of the security team. You can follow along. That QR code goes to slides.benjifisher.info, which are my GitLab pages. And what? Yes, I pressed the button. And don't be afraid of the outline. We're in the introduction right now. I'll talk about what is the OWASP Top 10. I'll talk about what is Drupal, and then I will go through 2 of the list of 10. And I'm not going to read them all now, but those 10 are the OWASP Top 10 vulnerabilities, and we'll have a little bit of a wrap-up at the end. I've cribbed some of my slides from Peter Wollinen's Cracking Drupal presentation. I've cribbed a lot of text from OWASP.org. Peter gave me permission, and OWASP has a Creative Commons license, just as all of my slide decks do. So, what is the OWASP Top 10? How many people are fans of acronyms? No? You are? Okay, someone else in the audience. OWASP is Open Web Application Security Project. P is for project. And it's a nonprofit foundation that works to improve the security of software. And it's not Drupal specific, so this presentation is sort of like, let's get off the island, let's see what Drupal looks like from an outsider's eye. And I don't know, maybe some of you in the room are new to Drupal and don't need to be told that, but a lot of people have been doing Drupal for a long time, and we sometimes need to be reminded to get out of our shell. Oh, and please feel free to interrupt me. I have a slide for questions at the very end, but often that's kind of too late. If you ask questions in the middle of the talk, then at least I know you're paying attention. So I'll do my best to answer them. The OWASP Top 10 is a standard awareness document for developers and web application security. It represents a broad consensus about the most critical security risks to web applications. And the list is updated every few years. The last time was 2021. I checked their website a few days ago. They haven't updated it since then, but no doubt they're going to update the list soon, and when they do, I'll have to redo this presentation. So what is Drupal? Again, trying to see it from an outsider's eyes. It's a content management system, a web-based content management system, or CMS. What does that mean? Well, Drupal says, enter data in my forms. I will save it to the database and create web pages from it. And what does the hacker say? Sounds great, let's get started.
I like it.
So, for example, if a hacker sees a text field labeled name, the hacker is likely to type in something like Robert, quote, right paren, semicolon, drop table students, semicolon, dash, dash. How many people have seen this example before? Okay. For the sake of the recording, I think it was about 2/3 of the room. And the hacker is just hoping that behind the scenes, when this text gets processed, assuming it's done in PHP, it'll look something like this. There will be some code, $SQL, a variable is quote, insert into students paren name, close paren, values, open paren, quote, whatever was input into that form, the variable $name, close quote, right paren, close double quote, semicolon. And if the hacker has typed that in, what this becomes is, I've inserted a line break, insert into students, name values of Robert, semicolon, and then a new statement, drop table students, semicolon, and what does the dash dash do?
Comment.
Right, it's the comment sequence in SQL. So anything left on the line after that point will be commented out. So this is what a hacker tries to do. This is what a hacker thinks of when you say, I'm a content management system, enter data into my fields, I'll save it to my database, and make web pages on it. And as 2/3 of you already know, that example comes from XKCD, which also has a Creative Commons license. It's number 327. I think most people remember this particular strip as Bobby Tables, but the actual title is Exploits of a Mom. So Drupal is a web-based CMS. It is also an active international open source software project. And the Drupal community is one of the largest open source communities in the world. We're more than 1 million passionate developers, designers, trainers, strategists, coordinators, editors, and sponsors working together. That's from drupal.org/about. I checked a day or two ago, and they haven't updated that particular paragraph since I last gave this talk. Drupal takes security seriously. The security team, of which I'm one of the newer members, is an all-volunteer group of individuals who work to improve the security of the Drupal project. Members of the team come from countries across 4 continents, so the sun never sets on the Drupal security team. The team was formalized in 2005 with a mailing list and has had 3 team leads in that time period. And that comes from security.drupal.org/team members, one of the few public pages on that site. So the team has been around for a while. Drupal takes security seriously and has a long-standing track record. So that's what is OWASP, what is Drupal. Any questions at this point before we go on? Cool. So at this point, let's have a look at the overview. There are 10 items in the OWASP Top 10. I do not try to cram all 10 of them into a 45-minute session. And in fact, I've only prepared some of them. So I'm prepared to talk about broken access control, which is number 1, cryptographic failures, injection, vulnerable and outdated components. And actually, I'm going to choose one because this is the first time I've prepared this particular one, server-side request forgery. So that's my choice. And when I'm done with that, it'll be your choice to choose a second topic to discuss. Okay? So, conclusion, not yet. Server-side request forgery, which is number 10 on the OWASP Top 10 list in 2021. And yeah, server-side request forgery is kind of long. It's always abbreviated as SSRF. And this text is cribbed from the OWASP site. SSRF flaws occur whenever a web application is fetching a remote resource without validating the user-supplied URL. It allows an attacker to coerce the application to send a crafted request to an unexpected destination, even when protected by a firewall, VPN, or another type of network access control list. So now you get to see my great graphic design skills. It's sort of like phishing, right? What's the idea of a phishing scam? Someone sends you an email and they hope you'll click on the link inside of it. This is basically the same thing, except your browser or the the hacker's browser is talking to the web server and trying to get the web server to click a link, to follow a URL that the hacker has supplied and go to the website, all your base or belong to us. Yeah, we've all been around long enough for that one. A similar example is that sort of a typical Drupal server architecture is that there's a sort of wall of trust, that there's one sort of mini network in your cloud provider typically, where you have the web server, which is running PHP, you have a database, you have memcache, you may have a Solr server, a bunch of other things, and within that network, connections are trusted, right? Like we're all on the same virtual machine, we're all running on the same physical hardware, connections between us are really fast, and we don't bother with HTTPS in those connections, do we? No, because we know who we're talking to. There's a little break in that double-barred wall of trust, and the browser comes into the web server through that hole. And if the hacker, through that browser, through that hole in the wall, can convince the web server to send an arbitrary URL to one of those back-end servers, it could do all sorts of damage. It could drop tables from your database. It could put in fake information or spam into the Solr server. It could degrade your cache, cause all sorts of problems. So that's what a server-side request forgery is. I looked, I confess I didn't look too hard, but I didn't find very many examples of SSRF in Drupal. This one is from a contrib module. It's the 15th security advisory. That's what SA stands for, SA's security advisory. It's the 15th security advisory from 2023. And actually maybe one of the advantages of doing the presentation in a web browser is that I can easily click on links. File chooser field, moderately critical, server-side request forgery, information disclosure, SA contrib 2023-015. So the project or the module is file chooser field. Has anyone heard of file chooser field? It has like 20 or 50 installs, so probably not. There's this brief scoring, 14 out of 25, which counts as moderately critical. And then, let's see, I claimed to like acronyms. AC is access complexity, which is basic, so it's fairly easy if you have a vulnerable site to exploit it. The A is authentication, so you need some sort of user account, but not necessarily an admin account. CI is confidentiality impact. I only studied up on these a few days ago. I'm trying to reinforce. CI is confidentiality impact some, so some private data can be exposed, not all data on the site. II is integrity impact, which is none, so it can't actually deface your site, it can't change any data in your database. E is exploit, so I think that means that there is a known malicious use of this vulnerability in the wild. TD is target distribution, which is all. So any site using this module is vulnerable. There's no way to mitigate it through configuration. And if you hover over it, you get all those things that I painstakingly memorized. I think if you click on this link, I never looked at this page until a few days ago. It talks about how many points are assigned to each option in the security picker and how they arrive at the number out of 25. and what levels are considered critical, less critical, moderately critical, and so forth. So that's one of my goals. I want to illustrate how Drupal communicates to its users, to all of us, when it finds a security vulnerability. This is an example. So it has this somewhat terse scoring mechanism. The security advisory always starts off with a brief summary of what the module does. It's usually copied directly from the module's homepage. The file chooser field allows users to upload files using third-party plugins such as Google Drive and Dropbox. So there you kind of see what the second step in that chain was. You talk to your web server talks to Google or Dropbox, and the vulnerability lets it show you information that you should not have access to. The module fails to validate user input sufficiently. Boy, do we use that phrase a lot, which could, under certain circumstances, lead to a server-side request forgery, vulnerability leading to information disclosure. In uncommon configurations and scenarios, it might lead to remote code execution. Remote code execution is sort of the holy grail of hackers. Like they get to run PHP code of their choice on your server. And the solution is to upgrade to the version that was released at the same time as the security advisory. So again, I copied over to the slide the details from the security advisory. I talked about the risk, the vulnerability, project name and date. One thing I didn't mention was the affected versions, anything below 1.13. So version 1.13 was released at the same time as the security advisory. So I think in the description of the talk I said there would be a few sides with code on it. So here's what the vulnerable code looked at like. It just used, this is a Drupal 7 module, by the way, so it uses the function system retrieve file. I did not look at what that does, but I assume it's basically copying a file from a URL to a destination. And the fixed code has that same line, return system retrieve file, blah, blah, blah. But first it does a test, and it makes sure that the URL starts off with a known string, https://dl.dropboxusercontent. And this would be the code for Dropbox. And the module comes with a variety of plugins, one for Dropbox, one for Google Documents, and 3 or 4 others. And if the URL fails that validation, then this function returns false. Okay, started the code long enough. And then there's a second part of the fix, and that was just one plugin. There were 4 or 5 changes similar to that, and just the fixed code first of all adds another test, PHP class name, which I guess PHP class name and remote file are extracted from an input file URL. And the fixed version of the code adds a test for that, makes sure it's in some array of trusted plugins, which comes from this new function that the module adds. And again, returns false if the PHP class name is not something recognized, it's not on an allow list. And the second part, after calling that method that was updated, tests to see whether that was false before going on with the rest of the function. So that was a fairly small, fairly simple fix. As the security advisory says, the user input was not sufficiently validated, so we add some validation. We don't just assume that the URL is benign. We don't assume that it's safe. We check that it's specifying something that we allow, both the plugin that we allow and then the destination that we allow. So I think that's it for SSRF. So now, as I said, it's your turn to choose. There we go. Vulnerable and outdated components, injection, cryptographic failures, access control. What would you like to see? Access control, broken access control. That's number one on the list, so that's a good one to look at. So the types of vulnerability are information disclosure, edit or delete by unauthorized user, cross-site request forgery, CSRF, and there's more. Basically, broken access control. Access can refer to access to just about anything. And speaking of acronyms, who knows what CRUD stands for? Shout it out. Create, read, update, delete. So each one of those should have access control. You shouldn't allow someone to create content on your site without some sort of authorization. Although we do allow anonymous comments sometimes, but much content on a website is restricted, but some is not. I'm sorry, I have that backwards. Much content on a website is unrestricted, is public, but some is not, some is private, and you have access control for that. So basically, if any one of the CRUD operations has broken access control, it counts. If read access has broken access control, we call it information disclosure. If update or delete, that's number two. Cross-site request forgery is kind of different. And yeah, I will say more about cross-site request forgery because it's a little complicated. I have a few slides for that. But let me start off with a horror story. What happens with custom modules? This was an actual module I was, for a site I was reviewing. And it had a custom access control function for user one edit, the edit page for the account user one. And the code left off a knot, right? So instead of granting access only to someone logged in as user one, it granted access to anyone but the person logged in as user one. And you know, it's one character missing, right? An exclamation point. So how do you protect yourself from making mistakes like that? Right? The wrong answer is, oh, we will be more careful next time. And that's the wrong answer to any question. How do you stop making any mistake? The wrong answers will be more careful next time. You have to have something positive you can do. You said test? Yes. Have some automated unit tests. Certainly if you're doing something as sensitive as access control, you want to be confident that you got it right. And so you should write some test cases and make sure that you got it right, that you didn't leave off the knot. What else can you do? So one of the points I like to make is that a lot of the things that are good for software quality in general are also good in particular for security. So automated tests being a great example. What are the other things that improve software quality that might also catch a mistake like this?
Existing classes and functions that already handle this kind of thing for you that might be in core libraries, things like that.
Yeah, you use existing classes to do it. Don't roll your own, in other words. Why the site thought they needed custom access control for the user edit form, I never did figure that out. And more generally, any code you write yourself, you know, we're all a little bit unrealistic when evaluating our own capabilities. But believe me, any code you write yourself is less secure than code that is written by others and reviewed by others and is open source, so has had eyes on it, has tests. So yes, not writing the custom code in the first place is perhaps the most effective way to avoid a mistake like this. And I sort of said some of the other ways.
Second opinions, other eyes.
Second opinions, other eyes, also known in the business as code review. So yes, the reasons I wrote down are code review, automated tests, and avoid custom code. And if customers knew the true cost of custom code, they would ask for less of it. Like, we know they wouldn't pay more for it. So now, what is a cross-site request forgery? CSRF. On mysite.com, I'm the hacker for the moment, and I own a site. And on that site, I put images. And in one image tag, I have as the source https://example.com/node/123/delete. So the URL, if example.com, is a Drupal site, and if I'm any good at all as a hacker, I can tell whether or not it's a Drupal site. The URL for Drupal site to delete node 123. So someone who happens to be an administrator for example.com visits my site and loads the page, and what happens? What's that?
Link and delete.
Right, the link gets visited. And this is different from SSRF. In server-side request forgery, the server would be making the request. In this case, it's the user's browser trying to load this web page, trying to load the image on this web page. It's the user's browser that's making the request. That's why it's not server-side. But since I got lucky, I, the hacker, got lucky, and an administrator for example.com visited my site, it's now an administrator for example.com who's making a request to the node delete form. So 2 questions: why doesn't this work? And 2, what incorrect assumptions expose a similar vulnerability?
Yes, it might not work because it's a GET request.
It might not work because it's a GET request.
And that
I think if I'm an administrator for example.com and I visit node/123/delete, it's normally a GET request.
But it presents a form there that has to be posted with a token in the form.
That's right. When I do visit that node delete page, it does not automatically delete. It gives me a confirmation form. And that's exactly why this particular example doesn't work. But hackers are very clever. They can come up with something more complicated than this. So the second question: what are the incorrect assumptions? And maybe it's an unfair question because I'm thinking of a sort of broad context. Anytime you're programming for a Drupal site, what are the assumptions you have to avoid that lead to problems like this?
Is that an assumption that the hacker is making, assuming that Drupal doesn't give a confirmation form potentially?
So I'm not thinking about assumptions the hacker might make or not make. I'm thinking about the assumptions that I'm no longer the hacker. I, as a Drupal module developer, site owner, whatever, what assumptions might I make that make me vulnerable to this sort of attack? That some hacker could insert an image tag like that onto the site that I maintain. So, go ahead.
I mean, is it just the assumption that okay, if something is protected with login, nobody's ever going to be able to nobody without access would be able to pull that page up. But they could use your own access instead as the site admin.
Yeah, so that's one assumption, and to summarize it for the recording, I'm trusting anyone who has successfully logged into my site. And of course, I'm trusting them not only to be competent, but also not to walk away from their computer while someone else can walk up to it and interact with it. I'm trusting them not to have some software installed on their computer that captures passwords and submits web requests for them. JavaScript, by the way, is really scary, isn't it?
So we can also have inline JavaScript. Find the button from delete and click on it, even without asking.
Yes, that's why I say JavaScript is scary, because yes, JavaScript can click buttons on web pages for you. So how to avoid cross-site request forgeries? Use confirmation forms so that no information gets lost on a GET request. Expect users to tweak URLs. They might just add /edit to the end of any URL they're allowed to visit and see what happens. They might add /delete to any URL they're allowed to visit and see what happens. And this one I think is a really pervasive assumption that we have to break. Do not assume that form requests come from the form you created. Yeah, like hackers are very good at creating post requests that look like they come from forms. Yes?
If you have CSP on your form actions, will that actually protect against that sufficiently?
If I have CSP, content security policy?
Yeah, content security policy, that form actions have to come from a certain domain. Is that a sufficient protection? So
does a content security policy protect form submissions? I'm not an expert in content security policy, or CSP. I'm not aware of how it protects form submissions. Anyone else in the room?
I think it kind of goes the other direction though. Like that would prevent it from submitting to another site, not prevent another site submitting to you, I think.
So you're saying the CSP would prevent me from having a form that posts to a random other site, but would not protect some random other site from sending me a post request for my form.
Might be wrong, but
Yeah.
Comment.
Yes.
So we can even set it as image URL. Okay, it should contain the word edit, delete, like image source. So we have a website.
So you're suggesting that at any time I have the source attribute of an image,
Yeah.
that I screen it for keywords like edit or delete?
It should not contain.
It should not what?
It should not contain those words delete, edit.
Okay, so my image URLs should not include the word edit nor the word delete. What if it's URL encoded? Then is it also banned? This turns into a hard problem, and I'm not sure how effective it is.
Well, that wouldn't be your site anyhow, that's the hacker's site. So you can't control what the image source is on my site.com.
That's right.
Example.com from my site.com.
That's right. You're exactly right. I have no control over this. This is the hacker's site. 5 minutes ago, I was the hacker, and it was my site, and that's when I added this. But now I'm the good guy, and I have no control over this.
Benji, I have a question. I'm not sure it's related to this or where it fits in the whole OWASP thing, but something I do regularly, I'm probably not alone. I'm on a website. It's specifically for course registration. Like they, go to a community college, they have a list of classes. It'll be like, oh, spring schedule's coming up. And if it's not available, but I know it's going to be available soon, I'll actually go into the form and figure out what are the different fields in order to 25, and I'll actually add it, and more times than not, boom, I'm able to access that particular thing and go and look at the classes, which is kind of cool. But where would that live on the hacking, whatever, I don't know, like you're just hacking the form, and I've done that many times.
Okay, so let me summarize that for the recording.
Okay.
Kristen points out that if she's looking at a list of courses and she knows that there's a course that's going to be posted but hasn't been posted yet, she might open up her browser tools and fill in some values for some of the form fields and submit, and more often than not it works, as you do. So I would say that this falls under two of the points I have here. The first one, expect users to tweak URLs. Oh, okay, so this isn't a URL, it's a form. But yeah, expect users to go in and fill in values of forms. And really, more closely, it fits into the next point. Don't assume that form requests come from the form you created. So if you do make that assumption, then you'll say, well, I only listed courses 3, 5, and 10. So I don't have to worry that someone will submit a post request asking about course 2 because it's not on the list I gave them. So that's exactly what I meant by don't assume that form requests come from the form you created. So validate, validate, validate.
I mean, and that's generally URLs as well. Don't assume anything that's being passed to your site through a URL is something that was actually from your site because it's a user editable field.
Right, don't trust any user entered content, whether it be a URL or something else. Another way to avoid CSRF is to use CSRF tokens, which I won't go into now, but I do give the link. There's a documentation page on how to use them. One of the nice things about Drupal is that forms are hard, and Drupal has been doing forms for like 20 years and has added all sorts of features to make them more secure. But basically, this is adding a token, some semi-random string. It's adding it to the form as a hidden field. That form is added when the form is presented to the user, and it's checked when the form is submitted. So that actually validates the assumption that the form request is coming from the form you created. It does not protect you from someone fiddling with the values of the form after loading it. All right, and I just said that. Remember, forms are hard. And getting back to what I said at the beginning, well, maybe I didn't actually say this. Web CMS is a terrible idea, right? Fill in data in the forms. I will save them to my database and create web pages based on them. From the security point of view, that is the worst idea I've heard in a long time. So CSRF in Drupal. Maybe I should update it with a more recent example, but there was one in 2021 in Drupal core. So the project was Drupal core. It was September 15th, 2021. Security risk was moderately critical, or 10 out of 25. And we've already gone through what those obscure abbreviations stand for. Vulnerabilities, cross-site request forgery, and there was a CVE, something vulnerability. Anyway, that's the
Exploit?
Yeah, the E is probably exploit. So a CVE is sort of a way you can look up any reported vulnerability, not just in Drupal, but in any web. Are CVEs just for web applications?
All software.
All software. Thanks. So again, this is how Drupal communicates. This is the information we have in a security advisory, in an SA. And it describes the vulnerability. The Drupal core media module allows embedding internal and external media in content fields. In certain circumstances, the filter could allow an unprivileged user to inject HTML into a page when it is accessed by a trusted user with permission to embed media. In some cases, this could lead to cross-site scripting. Okay, so basically this isn't an image element on a public page of a website. This is something on maybe a node edit page where you can select a media element to add to it, and some trusted but not completely trusted, like content editor user, could paste something into a text field or something that would then trigger cross-site request forgery when a more privileged user, someone with full admin access to the site, visited the same edit page. And the solution is to upgrade to Drupal 9.2.6, 9.1.13, or 8.9.19. Yeah, I really should update these slides. And I have a link here to the commit that fixed it. And let me just summarize that when editing a WYSIWYG field with a media embed, there's an AJAX request through jQuery, and the fix was to add a CSRF token to that request, and then the code that processes that request validates the token. Yeah, so I think I'm pretty much on schedule, and I should go to the conclusion. So we went through the introduction. We talked about the OWASP Top 10 in Drupal. We looked at broken access control. We skipped over cryptographic failures, injection, insecure design, and security misconfiguration. Skipped over a few more. We talked about server-side request forgery, and we're in the conclusion now. Here are some references. Again, if you got the QR code at the start of the talk, you can click on these links. All of my slide decks are, as I said, Creative Commons licensed, and I do them just with Markdown and PNG files, and GitLab CI. There's a link to the OWASP Top 10 and in general, and then the 2021 version. There's a link to the Drupal security team. The Drupal core release cycle, it's important to know the difference between major, minor, and patch releases and what the timing is for each of those. So just one piece of that is that the third Wednesday of every month is when there might be a security release for Drupal core. So that's when you should keep your eyes open. The list of security advisories. Contrib modules. I have to admit that I have my own biases. One, I'm biased against JavaScript. I think you may have picked up on that already. I'm also biased in favor of core and against contrib modules, so I have to remind myself from time to time that there are some contrib modules that are actually useful, like PathAuto. But for security purposes, there's the security review module, which checks for various common configurations that can be problematic. There's paranoia, which I think was more a thing in Drupal 7 than it is in modern Drupal, but it avoids PHP eval of anything in the user interface. The security kit, which is a module that does several things. It lets you set a content security policy, which is not easy. It sets origin checks, which may be related to what you were asking about before about limiting form submissions, origin checks against CSRF, and cross-site scripting. Garter is a Drupal distribution with security in mind. That should be replaced with a recipe, maybe, because No one likes distributions, never did, certainly don't now. It's very out of fashion. There's the two-factor authentication module, which really should have a stable release. If I had some time, I would help with getting that, because my gosh, Drupal ought to provide TFA out of the box. So, any more questions? I'm right on time. Yes?
As far as like how you guys classify the severity of the essays?
Yes.
Is it usually just kind of by the amount of mitigation that is sort of related to that? So can, like, a lot of these, they can be mitigated if you're already like have certain roles locked down or something. You know, there's like, it can be mitigated if you're not using a module in a particular way, or it can be mitigated if you are, doing something else on your site that kind of helps to reduce the footprint or the exposure to that vulnerability that's happened. Is that where that criticality of the essay comes from, or does it come from a mixture?
So the question is whether the security risk score comes from the difficulty of mitigating a vulnerability. This page I opened earlier is the definitive answer to that. And there are a bunch of things we consider, like access complexity. Access complexity, none. You just have to visit a particular page and something bad will happen. Basic, you have to go through a particular sequence, but it's not that complicated. Or access complexity, complex. So there are, 5 or 6 of these? 3, 4, 5. There are 6 of these things, and each of them we choose a value, and then this page actually lists out how many points each answer is worth, and you add them all up, and that's the score.
So mitigation is really just advisory, just to tell you, like, here's how you can keep yourself safe if you don't apply this update immediately.
Yeah, so mitigation, I think, fits into the last one, target distribution. Like the middle option is that default or common configurations are exploitable, but by configuration change, you can make it safe. So mitigation is part of the score, and there's this difficult decision of how much information to give. Like, we don't want to give so much information that hackers will say, oh, that's what's going on, this is how I can exploit it. Because we know that it will take time for people to upgrade. And on the other hand, we don't want to worry people unnecessarily. We don't want them to go through their whole deploy, test, look for regressions, and deploy reduction cycle if it's something that actually doesn't affect them. So there's a difficult balance in how much we say about them. And typically, if it's something that's easy to tell by looking at the changes we're making, you go, oh, these lines are in the in the such and such module in this particular thing, then you know more or less what path of actions you have to take on the website to trigger it. Then we'll save you the trouble of going through that and just tell you, such and such enabled in CK Editor might be a problem. But if it's more obscure than that, then we withhold the information. Yes?
Does the security team do code reviews of contrib modules?
Question is, does the security team do security reviews of contrib modules? And that's an important point. The security team is mostly reactive. Some individual members of the security team do go out and scan for vulnerabilities, but that is not a responsibility of the team. So we're reactive. Someone reports a security problem. If it's in Drupal core, the security team has primary responsibility for fixing it. If it's in a contrib module, we have more of an advisory role. And then our primary responsibility is coordinated disclosure. So it's our responsibility to make sure that the security advisory comes out at the same time as the release that fixes the problem. Yes?
Is there some way to use AI to kind of review any modules that you might want to use randomly? If I find some BAFO module that I want to, and it doesn't have the Drupal security check on it, do you have any experience with that?
Is there a way to use AI, artificial intelligence, to do security reviews? Short version of your question. I am skeptical. I'm prepared for the possibility that I'll be proved wrong. There are certainly, before AI became hyped up so much, there are automated security scanners, and they are notorious for producing a lot of false positives. They find a bit of code, and it might be vulnerable to this, but in the context of the whole thing, it's not. On the security team or anyone in a similar position, we're used to getting reports. I ran a security scan and it showed this, that, and the other thing, and here I'm reporting it to you. And we generally politely say thanks, but no thanks to things like that. For now, my understanding is that AI is just making that easier to do, that it's easier to generate false positives, in other words. There may come a time where AI becomes sufficiently well trained on common security mistakes that it does more than that. As far as I know, we're not there yet. That's it. Thank you all.